Okay, now I'll refer you, if you weren't able to get all three of these, you might find a little tricky. It's not really, but we'll see in a minute. But if you're not able to at least get these two, especially after having done the assignment in open math, I kind of refer you back to the video from last class, because it's very comprehensive on just about everything you need to know about linear functions. Okay. So I'm going to do this rather quickly. Here we got 4x plus 6y equals 36. Now, if you were, and most of you were in class, you didn't ever see me draw and subdivide a graph for an exponential function or a quadratic function. We didn't do any of that. Okay. What we do here is we say, okay, we write this statement down, x-intercept when y equals 0. It takes about 8 seconds to write it down and reinforces the first thing you do. The so is optional. I think it's a good idea because you understand the flow of the ideas and the concepts. So we let y equals 0, we plug it in, we solve for x. Now we know that when y equals 0, x equals 9, and there's a point on the graph. We only need 2 points to draw a straight line. It's a good idea to check against the third point, but okay, so we can start drawing the graph. Here we have it, and we have the point 9, 0, so I'm just going to draw a line here for x equals 9. If you want to mark off a bunch of points, okay, but after you mark them off, you might find that you don't have enough. You might find that you've marked off the points from 0 to 10 here, and the x-intercept is over there at 97. So you've wasted your time. Now you can make, instead of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you can make it 10, 20, 30, 40, and so forth. But you have to know where the graph is going to be. And to know where the graph is going to be, if you can find the intercepts, it's a good thing. It's a good way to do it. Okay. Then you just very quickly do that. All you do is plug in y equals 0 and solve for x. And now you got y is 0, plug in x equals 0 and solve for y. You get y equals 6, x equals 0. So when possible, it's a good idea to keep a relatively consistent scale. So if this is 9, it's pretty reasonable that this is 6. So here's y equals 6. And there are 2 points. Here's our line. Now, if you want to estimate the value for x equals 4, well, you could divide 9 into thirds and divide each third into 3, one way or another. You can use this as a basis for scaling the x-axis. You could use this as a basis for scaling the y-axis. Okay? Very straightforward. So here is the line y equals, sorry, it's not y equals, it's 4x plus 6y equals 36. Okay, now y equals 4/3 x minus 2. This one, y-intercept occurs when x equals 0, let x equals 0, you get y equals -2. You can also identify this as a slope-intercept form, mx plus b, and b is your y-intercept, okay? So you just say, well, b is -2, there's a y-intercept. Or you could say, let x equal 0, okay, it's -2. It's as easy one way as the other. You should see it both ways. Okay, so y-intercept's at 0, -2, and slope is 4/3. In other words, this is in slope-intercept form, so we're going to use the fact that we can just read off the slope. So how do we sketch the graph? We put line y equals -2 here. Mark the y-intercept. And then we move over. Well, this is rise over run. So the rise is going to be 4, the run is going to be 3. So we move over 3 units. And up 4 units. And what I'd want to see in your paper is just what I wrote. I'd want to see the arrows to show you that you know how to get another point given one of the points, right? There's a graph. Okay, well, I'm going to put both of these graphs instead of x, y axes. This point here is the point three, 2. If I start at 0, -2, and go 3 units, then my x value becomes 3. I'm at y equals -2, I go up 4 units. This has to be the line y equals 2. And I have the 2 points on this graph. Now I want to draw this function here. It's piecewise defined function. I'm going to go ahead and put x equals 9 out here. And I'm going to put y equals 6 here. And then I'm going to draw the line for the first function, which is the same as the first function we graphed. Then I'm going to draw 2 points for the second function. So if that's y equals 6, x equals y equals -2 would be about here. Y equals 2 would be about here. X is 9 here. So if I divide the interval between 0 and 9 into 3 more or less equal parts, this will be the line x equals 3. This will be the line x equals 6. And now I can put the point -2, 0 and the point 3, 2 on the graph. And there's a light line indicating this graph. Okay. Now, what this definition says is that this function, the y value is the y value of this function whenever y is less than 0. Okay? Well, when y is less than 0, that's over here. Okay, so here is the interval where y is less than 0. I said y. Okay. I wrote y here, so without thinking, I wrote y is here. It's not y less than 0. When I wrote that this is interval y less than 0, I realized something was absurd. And it was because I used y instead of x over there. So let's correct all that. Let's make it a little neater. Let's make these look more like x's. Okay, interval x less than 0. Whenever x is less than 0, we're on the curve y equals 4x plus 6y. There it is. Well, that means that I'm going to darken that part of the curve. Okay. This part isn't part of that function. I've sketched it here just so, we kind of need the line to know just where the line is here. Once we have these 2 points, we can draw the whole line, and then we darken the part that we want to use. Okay. Now, that's for x less than 0. X less than 0 means we put an open circle around that point. And then we switch to the line y equals x. Well, the line y equals x, I haven't drawn it because there are enough lines drawn on here, but it's a straight line through the origin. It would go through the point 6, 6. So if this is the point 6, 6, and it goes through the origin, here's the line y equals x. Okay, between x equals 0 and x equals 2, zero, is the interval down here. Now that's not part of your graph. We're just indicating that, okay, well, here's the line. X equals 2. So this line, this interval goes from 0 to 2 because that's what it says. 0 less than or equal to x less than or equal to 2. There's the interval. And the curve will follow the y equals x line from here to here. And this point will be included. And this point will be included. Then it follows the line 4/3 x minus 2. Y equals 4/3 x minus 2. Well, the last interval starts here and goes on. It so happens, I went to the wrong point here. To be clear. Okay. This part only goes up to the line x equals 2, because it only defined between x equals 0 and 2. Do we understand this? Does it make sense? And then when x equals 2, it suddenly takes the value of 4/3 x minus 2. Okay, well, that'd be 8/3 minus 2, which is 8/3 minus 4/3, which is 4/3. It's going to be on this graph. This is a graph of y equals 4/3 x minus 2. So we're on this line, steeper line. And that's going to give you a point here just below this point. I exaggerated. I've drawn it a little further below it is, but it goes on like this. And I could put an arrow on this and an arrow on this, and there's a piecewise graph. We're on this line until x equals 0, but not at x equals 0. Then we're on this line from x equals 0 to x equals 2, including both of the endpoints. Then we're on this line whenever x is bigger than 2. Okay? Now, your open math also tells you how to do these. You've encountered them in previous assignments, and sometimes I've made notes. Sometimes I've said, well, we're just going to address this in class. So this is a good time to do it. Okay? Get the idea? You have 3 different functions. One function from here to the left, one function between here and here, another function from here all the way to the right. You might want to go back and revisit those problems in your homework assignment. Okay, this is the range for test grades. Okay, these are normalized scores, which means that I've taken like a raw score of 40% becomes 60. Okay, a raw score of 90% is 90. Okay, so I kind of take the grades and kind of squeeze them together, but at the 90 level, I stop squeezing. Okay, A's need to be A's. And they were, we had 4 of them, I think. That was very good. We had a couple of B's, a few C's, and some D's, and unfortunately, some people didn't pass. I think I've said before, if you make a better percent on your midterm, it will replace this grade you made here. So like if you make 80% on the midterm, where you had only made 70% on this thing, so you had like 150 points, you make 80% on this thing, you get 80%, you get 400 in this one. Does that make sense? If you failed this one and passed this one, then you get that passing score on this one as well. And that's about the fairest thing I know to do. Okay, now we're going to go ahead and talk about absolute values, absolute value functions. I did tell you last week, if you wanted a copy of your test, you should email me and I would email you a copy. Well, today I was going to do it yesterday, but the copier was tied up. I printed off your tests and none of my comments printed, but they're right there in the PDF files. So I don't know why they didn't print, but they're in a little box. You got to click on the box and they expand. But every time I've ever done this before, they've been there. So I don't know what's going on. Probably doing something wrong, but I've never encountered that problem before. So I'm going to email everybody and tell you, email me and I'll send you a copy of your test. It just takes me 2 clicks. Okay. I'm not going to email you a copy of the test unless I get an email from you requesting it from your regular email. Because if I go through and try to email 15 tests, I'm probably going to send somebody's test to the wrong person. I'm probably, and there's a chance that I'll make a mistake, and that's a privacy violation. I can't do that. Okay? And I'm not going to try to post that PDF someplace because somehow that's going to fail to work. If you email me, I'll email you a copy of your test. Okay? All right, now we want to talk about absolute value equations and absolute value functions. Absolute value equations are generally, if they're linear, absolute value equations, they're really easy to solve. So let's just take one like that. Let's take absolute value of x equals 7. Okay? And somebody with their fingers, can everybody give me a solution to that equation? Okay, I'm seeing 7. Okay. Any other solutions? I'm not sure what that symbol means, but you don't have enough fingers to do it. So I think you're trying to tell me -7. Okay. I think I saw somebody try to tell me -7, which is true. Absolute value -7 is 7. Because the absolute value is what? If the number is negative, the absolute value is positive, right? So the definition is if x is less than 0, then you take its negative. So the absolute value of -7 would be the negative of -7, which would be 7. You're going to see that definition. Okay, so absolute value of x equals 7 in any case has 2 solutions. So how about the absolute value of x minus 3 equals 7? Well, we have to say that if the absolute value of something is 7, then what's inside that absolute value has to either be -7 or 7, right? Okay, so this gives you 2 statements. If the absolute value of this thing is 7, then this thing has got to be -7 or it's got to be 7. Now, that's the basic thing you got to know about absolute value equations. They always break into 2 equations, one of which has the absolute value equal to the negative of this number, the other, the absolute value equal to that number. So we're going to do a few of them. You're going to get used to it. Open Math will explain it and get you used to it. It's pretty easy to understand, but for some reason, it's so easy to understand that people do the homework, get it right, and then never do an absolute value equation right again. They get to the test and they just take the absolute value signs off and solve x minus 3 equals 7. Okay. I see it again, and again. I don't understand it. I don't understand how people are approaching the learning process in order to do that, but please don't. Okay. Please don't do that. Please understand that you break these into 2 equations. And then you can solve this. Well, you add 3 to both sides, you get x equals -4, and you get x equals 10. Then you can check, put -4 in here. -4 minus 3 is -7, and the absolute value of -7 is 7. And if x is 10, you got the absolute value 10 minus 3, which is 7. The absolute value, that is obviously 7. Does all that make sense? So you just remember, there's your procedure. So now if we have how about this? Absolute value of x squared minus 9 equals 4. That breaks into two equations. Write them down. Let me come around and see if you're getting the idea. Okay, this equation, just like the others, you don't care what's in here. What's inside those absolute value signs, whatever it is, it's going to either equal 4 or it's going to equal -4. So whatever's inside is going to equal 4, or whatever inside is going to equal -4. I recommend that you draw two little lines and put the word or in here. Matter of fact, I'm going to require that word or, because there's logic to it that can get easily confused if you don't sort out what how and is different than or. Okay, so anyhow, either x minus 9 equals 4 or x squared minus 9 equals -4. Okay, well, we can add 9 to both sides. In other words, we can add the equation 9 equals 9, and we get x squared equals 13. Keep the word or. And again, add 9 equals 9 or 13. Oh, no, I'm sorry, that's negative. It's be 5. Okay, what do you do with x squared equals 13? What do you do with x squared equals 5? Well, I'm going to give you a little bit more. We've talked about this. This means x equals plus or minus the square root of 13. Where x equals plus or minus the square root of 5. Now that plus or minus really means two things. It means x could equal square root of 13 or x equals negative square root of 13. So we get this from this. That's really an or statement. It's plus this or minus this. Or x equals square root of 5, or x equals negative square root of 5. So these two come from here. These two come from here. I recommend these little lines. I don't require them, but if you make a mistake, it could have been remedied by using those lines. Well, that'll be penalized as a mistake. I think you're less likely to make the mistake if you write things out the way I'm advocating. Okay, we'll probably want to review class from last time. I advocated a lot of things that you really ought to be writing into your work. That if you had, you probably would have done better on the quiz. Okay, and you'll probably do better on the test coming up closer to the end of the month. Okay. So that just couple of examples of how you can solve absolute value equations. It's not difficult. Now, solving the equation might be difficult. You might not have known what to do with x squared equals 13 or x squared equals 5. But now you do. So I could put any kind of ugly expression in here. And you could at least say that ugly expression equals 7, or that ugly expression equals -7. And now what in the heck am I going to do with that thing? Okay. So this is absolute value equalities. Now, absolute value inequality. So I'm just going to give you the rule. Absolute value of x less than 4. I'm going to draw a number line. Here's where x equals 4. Let's say here's where x equals 0. It should be clear that everything between here and here is part of your solution set. Any number between 0 and 4 is going to have an absolute value less than 4, right? Okay. Now, if we go into negative numbers, we go to -1. Is the absolute value -1 less than or less than 4? Give thumbs up if it is, thumbs down if it isn't. -1. What's the absolute value of -1? It's 1. Is that less than 4? 1 is less than 4. Okay. If you have $4 million, you have more than you do if you only have $1 million. And I feel sorry for people that only have $1 million. Okay. 1 is less than 4. Okay. If I go to x equals 2, -2. The absolute value of -2 is equal to what? 2, and is that less than 4? Yes or no? See some thumbs. What about -3? Yes or no? And what about 4? -4. Yes or no? Almost, but not quite, so the answer is no. X is -4, absolute value of -4 is equal to 4, and this has to be less than 4, right? So you can see that any number between -4 and 4 is going to satisfy this as long as the number isn't 4 or -4 or 4. So right there is your solution set. Make sense? So x is greater, -4 is less than x, which says that x is greater than -4, right? Any x in here, -4 is less than it. And x is less than 4. Any number in here has to be less than 4. That's how we write that out. Okay, so what about this? Absolute value of 5x minus 7 less than 13. I'm just going to tell you what you do with that. You do the same thing that you did here. Okay, whatever's inside of that absolute value sign has to be between -4 and 4. Whatever's in this absolute value sign has to be between -13 and 13. So we can say that 5x has to be less than 13, and I'm going to write the other inequality first. Then we're going to write it like this. Okay, 5x minus 7 has to be between negative 13 and 13. So it has to be bigger than negative 13 or greater than negative 13. And it has to be less than 13. Just like I could have said here, x has to be greater than negative 4. It has to be less than 4. This has to be greater than negative 13, and it has to be less than 13. It has to be both. If you just say only x has to be less than 4, that could include x equals negative 50. X is negative 50, this sure ain't true. It has to be less than 4, and it has to be greater than negative 4. Okay, so this translates like so. That's a rule, but there's an easy way to understand the rule. So it's just basically whatever's in between those signs has to be between negative 13 and 13. Otherwise, its absolute value won't be less than 13. If this thing is negative 14, well, then its value is negative 14, and 14 isn't less than 13. Okay, well, now we have two equations, and they're easy equations to solve. Right, it's this way, x is going to be greater than, let's be sure, 6 negative 6/5. X has to be greater than negative 6/5. And I'm not going to go through the details of solving these equations. And here, x has to be less than 4. So your solution is negative 6/5 less than x less than 4. And you could write that as the interval of the number line. Here's 4. Here's negative 6/5. And 0 will probably be about here. All right. And then you would again use open points because it's less than. If it's less than or equal, you'd close those points. Okay. Now, let's try this one. You know, I want to write up here, but there's a little bit of glare up there. And I hurt my left shoulder about a month ago. It's getting much better. My right shoulder's bothered because I've been overusing it. I really can't safely reach up there. I'm afraid I'm gonna tweak an injury, cause an injury. Okay, let's say we now have absolute value of x greater than 4. Okay. Again, I'm going to draw a number line. I'm going to put negative 4 here and 4 here. Okay. Now, if x is here, see where I'm pointing? Is its absolute value greater than 4 or less than 4? Greater than or less than? This point right here. Here's 4. That point. We just made that mark. Okay. Is the absolute value of that number greater than 4 or less than 4? Vote. Okay, some of you aren't voting. Well, that's greater than 4. Greater than means it's to the right of the number on the number line. The greater numbers go that way. Okay, so that number would be on it. And any number to the right of 4 would be on it, because every number greater than 4 is going to give you an absolute value greater than 4, right? Okay, so let's go to this number. Is this number? Okay, I'm seeing thumbs down. I see a lot of thumbs down because that number is less than 4. And it's still greater than 0, so let's put 0 in here. Okay, how about here? No, how about here? Well, that number is less than -4, right? So maybe that number is like -5. What's the absolute value of -5? It's 5. Is that greater than 4? Yeah, so any number beyond here is greater than 4. So one way to see it is just by thinking about what these numbers might be. But right there is our solution set. Now I don't use and here because X can't be both less than -4 and greater than 4. It can't be here and here. Any X value is either here, here, or in here, okay? And if it's here, it counts. If it's here, it counts. The other way of saying this is, well, okay, right there is your graph for X greater than 4. If I want the graph for absolute value of X greater than 4, if I want the graph for absolute value of X less than 4, well, that would be the graph from here to here, right? And unless X is equal to 4, if you exclude X equals 4, then X is either less than 4 or greater than 4, right? Or say it more properly, the absolute value of X is either less than 4, in which case it would be here, or it's greater than 4. I'm sorry, absolute value of X is either less than 4, which means it's here, or it's greater than 4, which means it's in one of these two regions. Or it's 4, which isn't included in any of them. So that an absolute value greater than something always gives you two sets. And is in one or the other. An absolute value less than a number always gives you one set. Okay, one interval. So then, for example, absolute value of 3x plus 6 greater than 4 breaks into two inequalities. (3x plus 6 less than -4), or 3x plus 6 greater than +4. And we can solve these inequalities. So it's just kind of automatic. When you see an absolute value equality, you have whatever's inside of the equality is equal to plus or minus the number outside, right? unless the number outside is minus, in which case you'd have no solution. And you worry about that in open math, you'll understand that easily enough. If you have an inequality where you got some absolute value less than a number, then that breaks into two inequalities with an and, as you saw in the previous. When it's an absolute value greater than a number, it breaks into two inequalities with an or. So that is a fairly easy pattern to visualize, to understand, and to practice. But when you practice it, write out some words on a piece of paper that reinforce what you think you're going to remember. If you write out some words and 99% of the human brains, it's going to be a help to remember, okay? So that you can bring those words out, translate them into symbols, and solve problems. Okay. Related to this, we might have an absolute value function. Y equals f of x is absolute value of x plus 5 plus 3. Your toolkit absolute value function you really need in a 4x4 window from x equals -2 to x equals 2, from y equals, I'm sorry, I had it from 0 to 2. We could draw it like this. If x equals 0, then y equals 0. Absolute value of 0 is 0. So we'd have a point here, and that's going to be our red dot. If x is 2, the absolute value of x is 2, so we got x equals 2, y equals 2. So we have this point, and we just do a straight line. If x equals -2, the absolute value is 2. So this is a toolkit. Y equals absolute value of x. You don't have to do a lot of subdividing. You can if you want. You know, if you wanted to divide it a little further, you could. But that's what the graph looks like. Now, what's a graph of absolute value of x plus 5 plus 3 look like? Well, you have to shift it 5 units to the left and 3 units up. Well, set of X and Y axes. We're gonna shift it, I said 5 units, negative 5 units horizontally. So I'm gonna just shift it over here. That's gonna be an axis of symmetry, just like you have an axis of symmetry for a parabola, you got an axis of symmetry for the absolute value function. And then we shift 3 units vertically. And then we make this picture. So the red dot is here. The window is 4 by 4, so you go 2 units to the left and 2 units to the right of the red dot. You get the line, you get X equals 3 here, negative 3. And X equals negative 7 here. And you go 2 units below and 2 units above, you get Y equals 1. Y equals 5. And here's your window. There's your graph. You can extend this graph. It's a little dangerous to extend some of the others we've done, but I can, where the vertex is. Of these lines. It's whatever number's in front of the absolute value. So if I had absolute 3 times the absolute value of X plus 5 plus 3, I'd have to stretch this window out, become 3 times as high in the graph, become 3 times as steep. So Open Math will talk about that sort of thing. And I notice that we're out of time. So we have the assignment on absolute value functions. When you get my email, just answer it. You don't even have to say hi. Okay, but if you want to say, would you please finally let me see my test? That would be okay too. Sorry it's been so long, but it's been well over a week since I told you, email me, okay? And almost nobody did. Actually, 3 or 4 people did.